Okay, let's look at this revision. Physics. Question 1 says figure 1.1 shows the speed time graph of a cyclist riding a bicycle. State the speed of the cyclist at time 15 seconds. Alright, so let me zoom in. At this time, what is the speed? So you go up and you reach the speed T where it ends there, then you go like that, then our speed is 8 meters per second. Next, describe the motion of the cyclist. So we are describing this motion of the cyclist, number 1, from 0 to 5 seconds. So from 0 to 5 seconds, what is the motion? Look at it, it's moving like that. 5 seconds is ending there, it is accelerating. Okay, so here it's what? Accelerating. Okay, just write acceleration. Next is that from time 10 here all the way to 20. So between that part there and there, what is happening here? You can see that the line is straight and it's constant, so that is a constant speed. So we can write steady or constant speed. Next is from 20 there all the way to 30 here. So from there to 30, so in that region there, in that line, what's happening? That is deceleration or decelerating. So you can write decelerating. You can write deceleration. Calculate the distance traveled by the cyclist from 20 to 30. So they want us to find the distance traveled by the cyclist from 20 to 30. So what you have to do is that look at the shape that you are forming. So we are forming a triangle. So the only thing that we need to do here is that since we are forming a triangle, so the area in this region gives us what? The distance. So the distance in this case to be equal to half. So let's call this height and let's call this one B. So that will be HB. So that will be half. You open two brackets. So what's your height? Your height is moving from this part to there, but it's of course from 0 to 8. So that will be 8. The B is moving from 20 to 30. What's the difference between 30 and 20? That is 10. So this should be able to give you, yes, because that's 5 and 8, that should give you 40 meters. So that is our answer here, 40 meters. Right, then we go to question 2. Question 2 says a person pushes a push chair. A young child rides in the push chair. This is the figure showing that. All right, so we have the horizontal force acting on the front wheel, this and this. They're acting, right? So one is going to the left side, the other one is going to the right side. Calculate the resultant force shown. Now look the direction of the person who's pushing the chair. She's going in that direction. So because she's going in that direction, our forward force to be 30. All right, that's all. So here we are getting to be 30 newtons minus 10 newtons. This will give us 20 newtons. So it's 20 newtons. Now what about the direction? Where is it going? It's going this side. All right, so you can say to the 30 newton force, or you can say in the direction of the motion, or you can also say to the west. All right, so you can say in the 30 newton direction. That's fine. Another person pushes a shopping trolley with a force of 40 newtons. The shopping trolley moves at a constant speed along a horizontal path. Calculate the work done by the 40 newton force to move the shopping trolley a distance of 50 meters. Now, all what you need to know is the formula for work. Work is equal to force multiplied by the distance or the displacement, by the way. So Here we have the 40 Newton as a force, and have the distance there as 50 meters, giving us 2000 joules. So 2000 joules. The next question is, the work done on the shopping trolley as it starts moving is transferred into another energy store. State two such energy stores. So when you are moving, you possess kinetic energy. That energy can be converted to other forms as you keep doing work. So from now, as it is starting to move, number one is that there will be kinetic energy. So we have kinetic energy because you have just started to move, so you are going to possess kinetic energy. Remember, when something is stationary, it has potential energy. The moment you start moving, you gain kinetic energy due to what? The velocity that you are going to gain. Then another one is that, remember that as you are moving, that trolley, even if you touch the tires, you find that they are hot or something. So that means some of the energy is being converted to what? To thermal energy or to heat energy. All right, so we can put thermal energy. Then I think we end there.